Welcome everyone to Statistics for Environmental Geography. My name is Erewan Indrayanto from Department of Mathematics. In this module, we are going to learn not only about formula, but we are also going to how to decode the landscape. Our goals is to give you the tools to turn raw environmental observation into meaningful geographic insight. Think of data as a raw community. It is everywhere, but it is messy. Statistics is the lens that brings it into focus. While geography asks where to find raw distribution, statistics asks why by looking at the process and probability. We are moving from simple observation to the world to predict its future. First, let's clear up some terms. Statistic data refer to numerical value of facts that we collect, like recording of 2,200 tons soybeans per hectare in South Sulawesi. And statistics, the science, however, is the methodology we use to analyze the data, such as we are using ANOVA to compare productivity across different regions. We will master both. Our work rests on two pillars. First, descriptive statistics, acting like a photograph to summarize the current state of the environmental, like soil pH or air quality. And the second is inferential statistics, acting like a detective. We use the samples to predict the whole, the quantifying uncertainty, and projecting the future tense, such as sea level rise. We can rarely measure each inch of landscape. Instead, we touch part of it to measure the whole. But beware of a sampling paradox. This is an example. We look at the test of water upstream in the Princeton mountain area. We will miss the urban pollution downstream. To find the truth, we must use the technique like random or stratified sampling to remove the bias. So, why does this matter? This is another example. Look at this UGM case study in soybean yields. We use the tools called ANOVA to ask which fertilizer actually works. So, statistics allow us to distinguish a significant difference from mere random change to ensure our agriculture decision is based on the fact, not luck. This is another example, the use of statistics in environmental geography. Clustering patterns that reveal how environmental phenomena like pollution and diseases spread across the region like Jakarta or Surabaya. This is another example that the use of statistics. Global averages that we use are often a myth. For example, what drives the economy in Java, like infrastructure, it's vastly different from what drives in Maluku, which relies on marine resources. So we will use like tools like geography, weighted regression, to understand how this relationship changes across space, filling the blank where the data is missing. So geography is a statistic. But by using correct statistical tools like a space-time cube, we can track dynamic like dengue fever in Yogyakarta. So we don't ask where is the disease, but where it is going next by calculating outbreak velocity and direction. So statistics can help us solve historical mystery. Like this example, by correlating a score of stratigraphy, scientists identified the 1257 Samalas eruption as the case of a global volcanic winter. This is environmental forensics, using statistical pattern to reconstruct the past. As environmental geographers, you will model the future. We will use CMIP6, climate projection, to understand probability. For instance, while drought intensity might stabilize, the frequency increasing. We define as not as schedule, but statistic probability, like the 100 years flood. Another example, closer to our home, we look at the parenthesis sign set dance. By using the multi-temporal DEMs and volumetric calculation, we quantified a net loss of over 2 million cubic meters of sands due to illegal mining and transport. So statistics produce the evidence needed for environmental protection. Working on tropical present changes like humidity and canopy cover that affect data prediction, we must also aware of modifiable area unit problems, MAUP. So how you draw borders changes your result. It is a reminder that the map is not the territory. So data is raw and sellable, but we must remember the human element. So whether it is nickels mining in Halmahera or pitline restoration in Sumatra, we must balance economics metric with indigenous livelihood. Statistics should serve people, not just spreadsheet, not just number. So by using a correct statistical tool, we will use modern ecosystem tools like ArcGIS Pro for visualization, R or Geoda for modeling statistics that gives geography as a region, visualization gives statistics as a choice. So this is what we are going to study next when we are going to explore this about statistics in geography. So are you going to ready to explore more? Let's begin.